We're going to measure the speed of light using some chocolate. You want something that's wide and flat so that you can have a big area to work with. The first thing you want to do is take out the plate that spins. So this is good for food but bad for science, because this will spin your food around, make sure it gets evenly heated. That's not what we want. So as you just saw, you want the same part of the chocolate to get heated up, so that you can measure exactly where the hot spots are and figure out the wavelength and thus the speed of light. So let's see what happens actually if you leave this in. So we'll do a test case. Alright, so here we go. We've got our chocolate bar in the microwave, but we've got the round spinny thing in. I don't know what this is called. And we're going to see what happens when we leave that in. So this shouldn't work, because now the bar is going to get spun around and heated sort of all over the place. So close that. Let's go for, I don't know. Let's do 3 minutes and see what happens. Alright, so here's what we get when you just left the spinny thing in and let it go for a few minutes. It's kind of just sort of smushy all over. There's no sort of obvious hot spots. So yeah, there is still some kind of pattern going on. So actually there's a bit of an arc here, which is interesting because we expect there to be a hot spot, but now it was spinning. So actually we get sort of an arc instead of a bunch of points. So, okay, that's kind of interesting. We learned something there, but that's not what we want. Remember, we want to find two sort of hot spots, measure their distance, but okay, cool. Good to know that this kind of works the way we expected. Alright, so here's an interesting result. In this case, actually, we only got one node, just because of the way I aligned it. If you look at the other one, you can see one of the nodes is close to the edge, so that's one thing to be careful of. So actually, I can't really use this experiment because we need two nodes to measure the distance between the antinodes. Alright, so here's the second run I just did, and if you compare it to the first run, there's actually a problem in this case. Because of the way the chocolate was oriented, it only hit one antinode, so there's only one hotspot. And that's just, again, because of the way the waves are oriented within the microwave, I just happened to pick a spot that didn't get two antinodes. And that's, we're doing science, we're doing an experiment, it's how it goes sometimes. It's not math, it's not just 3 + 3 = 6, sometimes there's a little bit of a wiggle, but that's fine. I'll just pop another one in and we'll get some more measurements. Ow! I'm using Hershey's brand chocolate, which is not a sponsor of this video. It was just what they had at the supermarket. You could probably try doing it with different chocolates. I actually have almond and no almond. I was not careful in picking the same chocolate. If this were a proper experiment, you kind of want to be more precise with what you do, but this is fine. Got our other one there in the microwave. Yeah. One thing to note, you can actually, this ends up being pretty good to eat, so the chocolate gets kind of crunchy. It's a little burned, but it's actually kind of a good snack. So I'm probably going to eat that when this is all done. One thing to note is that you can actually eat this when it's done. All you've done is cook the chocolate, and it's kind of crunchy and a good snack, so that's kind of a fun outcome. I'm probably going to eat this afterwards. Probably going to eat all 5 bars.